All right, so it seems like someone out there is really fascinated by random numbers.
Because they sent us a ton of stuff about them.
Like, we're talking flowcharts, code examples, the
Wow.
whole shebang.
So get ready to demystify randomness, because that's what we're diving deep into today.
Sounds like fun. You know, it's fun
Most
to...
people don't realize how much thought actually goes into creating something that seems so, well, random.
Right. It's one of those things we all kind of take for granted.
Like, we all know what a random number is.
Or at least we think we do.
But when you actually stop and think about it,
Yeah.
how do you even define a random number?
And more importantly...
Why do we even need them?
Those are great questions. At their core, random numbers are all about bringing unpredictability into controlled environments.
It's like,
Think about rolling a die, right? You know there are only 6 sides,
So you know the possible outcomes.
but you don't know what each roll is going to be.
Okay, I get that.
But it's not like we're all walking around rolling dice to make every decision.
So where do random numbers actually come into play in the real world?
Oh, they're everywhere. Think games.
From the roll of virtual dice in a video game to shuffling a deck of cards online, random numbers keep things fair and unpredictable.
Makes sense. You wouldn't want to play a game where the outcome was always the same.
Right.
But it's not just games, right?
Definitely not.
Random numbers are essential for computer security.
You know, making sure those randomly generated passwords are truly hard to crack.
And in scientific research, they use them in simulations to mimic real-world scenarios with all their unpredictable variables.
Wow, I never realized how much we rely on something that's supposed to be random.
Speaking of which,
Yeah.
I noticed in this source they mentioned something called the random number function.
It sounds very official. What's that all about?
That's just a fancy way programmers talk about generating a random number
Okay.
within a specific range.
So you give the function a starting number and an ending number, and it picks a random number in between.
So kind of like setting boundaries for the chaos.
Exactly.
Imagine you have the function random number 1, 10.
Okay.
That's telling the program to pick a random whole number between 1 and 10.
Okay, that makes sense.
But here's where my brain starts to short circuit a little.
If computers are just following instructions, how can they create something that's truly random?
It seems like a paradox.
That's the million-dollar question.
And it leads us to the fascinating world of pseudo-randomness.
You see, computers are great at following rules.
But true randomness.
That's a whole different ballgame.
All right, you've piqued my curiosity.
Let's unpack this whole pseudo-randomness thing, because I have a feeling it's about to get really interesting.
Okay, so you just dropped the term pseudo-randomness,
It's like you're saying there's a formula for spontaneity.
which my brain kind of rejects.
And you would be right to think that. True randomness.
Is incredibly difficult to achieve.
Even for a machine as powerful as a computer.
They excel at following instructions.
Not necessarily at breaking free from them.
So how do we get from computers following rules?
To generating numbers that seem completely random.
Where does this pseudo part come in?
Think of it like shuffling a deck of cards.
If you follow the same steps every time,
The order, while different, is actually quite predictable.
but if you throw in a random starting point,
Say, picking a card blindfolded and starting the shuffle from there.
suddenly the outcome is far less certain.
So computers use a similar trick.
Precisely. They use formulas
Or algorithm.
designed to produce sequences of numbers that pass all the tests for randomness.
But at their core,
They're still just following a set of instructions.
hold on, we have a flowchart in the source material here.
Can we use that to illustrate this whole formula thing?
Absolutely.
This flowchart is a simplified example of how a computer might generate a random number.
It starts with a variable.
Let's call it x.
Okay.
In this case,
X is set to 81.
the next step is to calculate the square root of x.
So, like, back to high school math class.
Right.
And in this specific example,
The square root of 81 is 9.
so the output of this flowchart would be 9.7.
Now,
Imagine that calculation being much more complex.
maybe it involves multiple variables,
So,
even trigonometric functions.
the point is...
It's still a series of steps based on mathematical operations.
Okay, that makes sense. Computers are really good at math, after all.
But if it's always the same formula,
How do we get different random numbers each time?
that's where the magic of seeding comes in.
Remember that random starting point we talked about with shuffling cards?
The seed is basically a numerical starting point for the random number generation process.
So a different seed means a different sequence of random numbers.
Exactly.
It's like adjusting the starting point on a combination lock.
A tiny change completely alters the final outcome.
I'm starting to see the method in the madness.
But why does all this matter?
Who cares if a computer is having an existential crisis about true randomness?
It matters more than you might think. For example,
Let's say you're running a simulation to test how a new traffic system might work.
okay,
If the random elements in your simulation aren't actually that random,
your results could be skewed.
leading to inaccurate conclusions.
Okay, that makes a lot of sense.
So it's not just about the numbers themselves.
It's about ensuring that the processes that rely on those numbers
Are actually as unpredictable as we need them to be.
exactly.
Now, let's take this concept of pseudo-randomness.
And see how it plays out in a more concrete example.
All right, so we've talked about the philosophy of pseudo-randomness.
But how does this actually play out in a real-world scenario?
Can you give us an example?
Absolutely. Let's go back to that lecture hall example from your source material.
Imagine you're a teacher, and you want to randomly assign new seats.
You know, just to shake things up a bit.
I can already picture the students groaning,
There it is.
though secretly they probably love a good seat shuffle.
Exactly.
Now, this flowchart shows how a programmer might use random numbers to tackle this challenge.
We have the layout of the lecture hall,
Rows and columns.
and then our trusty random number function comes into play.
Okay, so it looks like random number 120 is determining the row number.
Makes sense, there are 20 rows in this example.
But then it gets interesting. Why are there two different functions for the column number?
That's where things get clever.
Notice how the left side of the hall uses a range of 1 to 15 for the column number.
While the right side uses 16 to 30,
Ah, so you're making sure that a student assigned to the left side
doesn't end up with a seat number that doesn't exist.
It's like that controlled chaos we were talking about earlier.
Precisely.
We're using random lists to assign seats.
But within constraints that match the actual layout of the lecture hall.
And that's just one small example of how these seemingly abstract concepts we've been discussing
Actually have very practical applications.
That's what I love about these deep dives.
We've gone from what is a random number
To understanding that true randomness is surprisingly complex.
with computers using formulas and seeds to create the illusion of unpredictability.
And now we see how it all ties back to something as relatable as rearranging a classroom.
And it goes even deeper than that.
Since true randomness is so hard to come by,
It makes you wonder about all the things we rely on it for.
like online security.
What if someone figures out the formula and the seed used to generate those random passwords or encryption keys?
Okay, now that's a thought I'm going to have to sit with for a minute.
It's a bit unsettling to think that something we perceive as random.
Might not be as unpredictable as we think.
It's definitely a reminder that there's often more to things than meets the eye.
The next time you encounter something that seems random,
Whether it's a shuffled playlist
a computer-generated password,
or even just the toss of a coin.
take a moment to appreciate the intricate dance between predictability and chaos that's happening behind the scenes.
Great advice.
Well, there you have it, listeners.
We've taken a deep dive into the world of random numbers,
Exploring everything from their definition and purpose.
to the fascinating world of pseudo-randomness and its real-world implications.
Hopefully you've come away with a newfound appreciation for the subtle complexities of something we often take for granted.
Until next time, keep those minds curious.